Okay, now in example number 11, we want to be able to graph a rational function. So how do we go about this? If we're given a rational function, we have to sketch the graph. So there's 8 steps that we need to follow. The first one is we need to evaluate the function at 0 to find the y-intercept. Step 2, we have to factor the numerator and the denominator. Step 3, for factors in the numerator not common to the denominator, determine where each factor of the numerator is 0 and find the x-intercepts. Number 4, find the multiplicities of the x-intercepts to determine the behavior of the graph at those points. Number 5, for factors in the denominator, note the multiplicities of the zeros to determine the local behavior. For those factors not common to the numerator, find the vertical asymptotes by setting those factors equal to 0 and then solve. Number 6, for factors in the denominator common to factors in the numerator, find the removable discontinuities by setting those factors equal to 0 and then solve. Number 7, compare the degrees to the numerator and denominator to determine the horizontal or slant asymptotes and then sketch the graph. For example number 11, we want to be able to graph the rational function. So we're going to sketch the graph. So we can start by noting that the function is already factored, saving us that setup. Next, we will find the intercepts by evaluating the function at 0 gives the y-intercept. So we're going to plug in 0 for x, and in the numerator we get 2 times negative 3, which is negative 6. In the denominator, we get 1 times negative 2, which gives us a value of 3. So therefore, the y-intercept is at 0, 3. To find the x-intercepts, we just need to set the numerator equal to 0. But again, just showing how to solve, we multiply both sides by the LCD, leaving us with the numerator, which is x plus 2 times x minus 3, which is equal to 0. You don't have to do that step, but I'm showing you there so you know how to go about that. So now the x-intercepts are at 2, negative 2, and 3. So therefore, the x-intercepts are at negative 2, 0, and 3, 0. Now, to find the vertical asymptotes, we determine when the denominator is set equal to 0. So we're going to set both of our denominators equal to 0. So we end up getting x, which is equal to negative 1, and x, which is equal to 2. So therefore, those are our vertical asymptotes. Now, there are no common factors in the numerator and denominator, which means there are no removable discontinuities. Finally, the degree of the denominator is larger than the degree of the numerator, telling us the graph has a horizontal asymptote at y equals 0. So over here, the horizontal asymptotes, the degree of the numerator is 2, the degree of the denominator is 3. So therefore, because 2 is less than 3, then we know that the horizontal asymptote is at y is equal to 0. Now, to sketch the graph, we might start by plotting the 3 intercepts, since the graph has no x-intercepts between the vertical asymptotes and the y-intercept is positive. So we know the function must remain positive between the asymptotes, letting us fill in the middle portion of the graph as shown. So we're going to plot our x-intercepts, which is negative 2 and 3. And then we have our y-intercept at 3. And then again, we cannot go below, and it's going to be above the x-axis, again, because the function must remain positive between the asymptotes. Now, the factor associated with the vertical asymptote at x is equal to negative 1 was squared, so we know the behavior will be the same on both sides of the asymptote. The graph heads towards positive infinity as the inputs approach the asymptote on the right, so the graph will head toward positive infinity on the left as well. For the vertical asymptote at x equals 2, the factor was not squared, so the factor will have opposite behavior on either side of the asymptote. You can see this in the figure. After passing through the x-intercepts, the graph will then level off toward an output of 0 as indicated by the horizontal asymptote. So again, here are your 3 intercepts. we can see here that on both sides, it's going towards positive infinity of the vertical asymptotes. And your horizontal asymptote is y is equal to 0, which is why this doesn't go below. And therefore, there is your graph.